Hello everyone, welcome to my video. And today I want to discuss about the basic geoprocessing tool in ArcGIS 10.6. So let's start. First of all, we have to open ArcGIS ArcMap, and here I want to solve a project by using geoprocessing tool. So let's see what's the project. So in our project, we have been given the following spatial dataset with BTM projection of for Rajshahi City Corporation, and that is RCC, and two dataset have been given to us. First, education facilities, and second, ward boundaries. And we have to prepare RCC boundary polygon using spatial data of ward boundary. So for that, first of all, we have to add the project data. For that, and this is two dataset which has been given to us to solve this project. So I'm gonna add this into my ArcMap. So here we can see educational facility dataset, which is basically primary school and their location, and second is RCC ward boundary. So here you can see how many wards RCC has. So now we have to make RCC boundary polygon using a spatial data of ward boundary. So for that, we have to use a geoprocessing tool, and that is dissolve. Dissolve tool basically used to aggregate feature based on specified attribute. Like if our input is this and there is similar attributes, so it will give the output of like this. So our input feature would be RCC word boundary, and we'll make a new folder, named it as RCC educational facilities distribution distribution. And here I want to name it as RCC boundary, and click save. Click OK. So after the geoprocess, it will give a output like this, and as we can see, this is RCC boundary. So our first problem has been solved. Then in second problem, we can see taking 1 meter buffer as a standard service area of primary school. So first we have to take a buffer for each educational facilities of 1 kilometer. So for that, we will go to geoprocessing and buffer. We will make input feature at educational facility and output as buffer 1 km and click in save, and then linear unit of 1000 meter. Obviously it's a planar method and no dissolve type, so click OK. So after that we will have this type of output. And now okay, now it has been asked to calculate the percentage of only a served area, overserved area and unserved area within RCC area. And for that we have to go through some geoprocessing tool and make the division of RCC boundary as served, overserved and unserved area. So for that we have to go to the argmax again, and now we want to dissolve this buffer as it is served area. You can see this, all the buffer ring has been served by this educational facilities. So now go to geoprocessing tools and dissolve. So input feature is buffer 1 km, output served as all the area which are into this buffering has been served by educational facilities area is all. So now okay, and clicking here. So it is been done, and now we can see there is a lot more of area which has been overserved, like 1 or 2 or 3 educational facilities are available within the 1 km radius. So that is overserved area, and to find out that area we want to do intersect. Well, intersect is some tool which is like input one features and then intersect feature, and output will be only that particular area which has been intersected by both. So if any area which been intersect by each other, that will be cutted out and other will be erased. So input feature is this, and we want to over serve unresolved this. We don't want to join any attributes, so we are clicking OK. So the output has been shown for intersect tool, and as we can see the area which are intersected by more than one buffer, that is been cutted out. So we want to dissolve this and make it one to dissolve or serve dissolve. Okay. Now, as we can see, this is overserved area and this is served area, and into the background this is RCC boundary. So now we want to make one feature class of served and unserved area. So for that we have to go to Arc toolbox and we have some tool in this analyst toolbox, and into overlay we have identity, and identity mainly computes a geometric intersection of the input feature and identity features. The input feature or portion thereof that overlap identity feature will get the attribute of those identity feature. Basically, if we get as our give as input a feature and then select the identity feature, it will cut the features as of the identity feature. So for making the two feature into one, we have to just served area and then identity with the overserved dissolve, and this is we're gonna call served over served area. So now you're gonna save it and clicking OK. So now there is one feature class which has been included with two, one is served and one is overserved area. So if we want to check it out, so there is two polygon, this one is served and this one is overserved. So we are going to add a field. I'll name it as status text and clicking it as OK. So now we want to add this field. So this is served over certain area. This is being overserved and this one is served. So I am saving the changes. Now as we can see in the background, this portion of RCC boundary has not been served So people from here have to make more distance to get access to the educational facilities. So we are going to call this portion as unserved, and we want to make the served overserved area into the RCC boundary. So for that we want to identify. So now we have to identify RCC boundary into served and overserved area, and the portion which has been not intersect by served and overserved, we will declare it as unserved. So for that we will go to our toolbox and identify. Input features will be RCC boundary, and identity features is served overserved area. And now we want to, so we are clicking OK. So the output, as we can see in the attribute table, there is 3 polygon, and one is served and one is overserved and other one is unserved. So we are going to add the field and named it as unserved and saving the edits. So now we are just off other layer in this art map and change the symbology as overserved will be green, served as yellow, and unserved is red. So just clicking apply, and as we can see in RCC boundary, this green portion has been overserved, yellow portion is served, and red portion is unserved. And now the, we have been asked to calculate the percentage of served, overserved, and unserved area within RCC boundary. So for that, we have to add a field called area. Uh, it will make the unit of acre, and the type is float. Okay. Now we want to calculate this field, and for that just right click on the area acre field and calculate geometry. So we want to calculate the area, and coordinate system is BTM, and we want the unit as acres. So clicking it OK. So this says that we have overserved area 10,744 acre, served area of 773.99 acre, and unserved area of 352 acre in RCC boundary. And now we have to calculate the percentage of served, overserved, and unserved area in RCC boundary. So for that, we have to just add a field, and I'm making this name as percentage served, overserved, and unserved area. And I'll make it as float. Now, first of all, we want to know this field value 11,870 acre. I will copy that to use in further analysis. And now we want to calculate the field as area acre divided by the saved area of RCC boundary, then multiply this by 100. This will give an output of percentage served, overserved, and unserved area in RCC boundary. So I'm clicking it as OK. So here we can see that RCC area has 90.5% of overserved area, 6.52 as served, and 2.97 as unserved area. So this is the answer of 2.A question. Now we have to calculate the percentage of service area, overserved area, and unserved area within the RCC area against each ward. So for that, we have to intersect served, overserved, and unserved area by RCC ward boundary. So by intersecting these two features, we will have the value that it is served, overserved, or unserved into the RCC ward boundary. So we want to intersect served, overserved, and unserved area and RCC ward boundary. So make this as served, overserved, and unserved against RCC ward. So I'm joining all attributes and clicking it OK. So after that, if we open the attribute table of served, overserved, and unserved against RCC word, we will find out that it has arranged the data as served, overserved, unserved of each word. So our problem is to calculate the percentage of served, overserved, and served area within the RCC area against each word. So for that reason, we have to calculate the area of served, overserved, unserved against each word. So we want to calculate area. This one, we are going to add field called area acre and against each word. So I'm going to write word, and it is float. So this area will saved as area underscore and acre underscore. So make it as word and hit as okay. So now if we click calculate geometry and area measuring with the unit of acres, click into okay. So now so we can do it in Excel. So now I want to so now we can see that what 2 has total of 1726.63 acre, and it has been overserved 12.1205 acre, served 310, and unserved 210 acre. So this is the solution of question 7 of calculating served area, overserved area, and unserved area within the RCC area against each word. Now we have to just so here we can see the percentage of served, overserved, and unserved area against RCC word, each word. So this is the answer of question 2. Now the third question is about to calculate the percentage of population for underserved, overserved, and unserved area within the RCC area. So now the third question is calculate the percentage of population for underserved, overserved, and unserved area within the RCC area. So as there is density of 91 as 3467, but we don't know the unit, so that's why we are assuming that per acre density, or so we want to calculate the population. So for that we are adding a field called population. Population of served, overserved, and unserved. So population served, overserved, and unserved, and the type of the data is short integer, as population can be fraction. So we'll precise it as 10 and clicking it as OK. So now we want to calculate the population, and this is the area which has been served, overserved, or unserved, and this is the total population that are lived within that area word. So if we divided this by the word area and multiply this by area acre word which has been served, overserved, or unserved, so we'll get the population which has been served, overserved, or unserved. So for that we will just click this and calculate field. So we will divided this population by ward area and multiply this by area acre of served, overserved or unserved within the ward. So we are clicking this and okay. So we get the population that is for served, overserved, or unserved within RCC each word. So therefore, if we copy all the data and here, so now we go to the pivot table and click it as okay. Now the pivot table which will have so here we can see 96.58% of RCC boundary has been overserved. Served is 2.40 and unserved is 1.02% of population. So this is the answer of question 3. And now we want to calculate the percentage of population for underserved, overserved and unserved area against each ward within RCC area. So for that we just have to so total worksheet. Now just have to set RCC word as rows and status as column, and now this will be population. So as we can see, this is the population which has been assembled into as served, overserved and unserved against each word in RCC area. And now if you want to know the percentage, so that's why. So 69.79% of road 2 has been overserved, 17.96 been served and unserved is 12.25. So that's how we can find the answer of percentage of overserved, served and unserved population against each ward in RCC ward boundary. Thank you very much for staying with us.